Welcome back to The Explainer. Today, we are jumping right into a technological leap that is actively rewriting the rulebook for aviation. We are breaking down exactly how 2026 hydrogen combustion technology is powering the next generation of heavy-lift military drones. We're uncovering a massive shift happening right now in propulsion, a shift that completely moves us away from the heavy limitations of batteries and straight into a future where fuel can essentially be pulled from thin air. Okay, let's dive into this. Here's our roadmap for today. We're going to cover 1. The drone propulsion problem. 2. The hydrogen fuel solution. 3. Scaling up, H2 combustion. 4. The 2026 heavy lift milestone. And finally, 5. Transforming military logistics.
So, first up, the drone propulsion problem. Why exactly is everyone so desperately seeking alternatives to current drone tech?
Well, operators are facing a really severe dilemma right now when it comes to powering these next-generation drones. On one side of the coin, battery propulsion suffers from extreme weight and super low endurance. I mean, gravity is a harsh critic when your battery literally weighs more than your actual payload. It leaves virtually zero capacity for heavy transport over any kind of long distance. But then, on the other side, traditional internal combustion engines, or ICEs, they're simply too inefficient, too noisy, and they run way too hot for operations that absolutely require stealth and reliability. Militaries and commercial operators are just stuck between a rock and a hard place here.
Which brings us to Section 2, the hydrogen fuel solution. Overcoming those limitations requires a fundamental, ground-up shift in energy density, and that is exactly where hydrogen enters the picture. Listen to how a Defense One report quantifies this absolute miracle for military drone development. We have a tank of hydrogen, a small amount, about 1 pound. We're getting about 10 hours of flight time, about 100 miles. Just think about that ratio for a second. 1 single pound of fuel is delivering 10 hours of flight. That is a level of energy density that traditional batteries simply cannot even begin to compete with.
So the crucial point is how this actually solves the weight problem we just talked about, and it's made possible by the hydrogen fuel cell. It's an energy system that incredibly efficiently creates electricity from that very small amount of hydrogen. The fuel goes in, reacts, and powers the drone's motors. You get all the quiet, efficient benefits of electric propulsion, right? But you completely circumvent the massive weight penalty of lithium-ion batteries. You maintain the endurance of a liquid fuel, just without the heavy footprint.
Moving on to Section 3, Scaling Up, H2 Combustion.
Now, while small fuel cells are absolutely fantastic for lightweight surveillance drones, heavy-lift military drones require industrial-scale power density. To scale up for those heavy-lift applications, we actually have to look past small fuel cells to massive industrial internal combustion engines. For marine, locomotive, and heavy drone logistics, the industry is shifting toward burning hydrogen gas directly to generate massive mechanical power. It is a true David to Goliath scalability when you compare it to that 1 pound tank we just looked at.
And this brilliantly illustrates the engineering behind it. Making this massive scale possible requires incredibly advanced fuel injection to keep the engine from literally destroying itself through pre-ignition. Companies like Borg-Warner have developed highly specialized direct injection and port fuel injection systems that allow these engines to achieve stable, fast-burning, zero CO2 combustion. Engineers are basically taking existing, deeply proven powertrain architectures and adapting them to safely and powerfully burn hydrogen at industrial scales.
And this is far beyond theoretical at this point. Bosch is currently tracking over 130 worldwide original equipment manufacturers who are either planning or actively running hydrogen engine R&D projects right now. That is immense global validation. The technology is being rigorously tested, validated, and prepped for deployment across the entire commercial and military landscape.
All right, Section 4, the 2026 heavy lift milestone.
Let's move to and see how this builds together, because this R&D is operating on a very strict near-term timeline. Following the initial 2024 rollout targets for port fuel injection systems, robust and highly efficient direct injection is slated for 2026 and beyond. This progressive engineering leads straight to a massive scheduled leap for heavy lift capabilities.
And all of this culminates in a historic commercial milestone slated for July 2026, a record order for next-gen heavy-lift hydrogen drone powertrains. This is the exact moment we cross the threshold from a slick engineering concept into an active, deployed commercial reality capable of moving significant tonnage. It's happening.
Finally, Section 5, Transforming Military Logistics.
The logistical and tactical implications on the ground here are just staggering. Because you can generate hydrogen on site using just solar power and water, militaries can now deploy localized refueling stations directly to remote outposts, like island bases. Think about what this means for the Marines. A unit deployed in an isolated area can essentially pull heavy-lift drone fuel from thin air 24/7. This completely severs their reliance on highly vulnerable, long-distance liquid fuel supply chains.
So, I'll leave you with a final thought to consider today. If remote military outposts can successfully generate heavy-lift transport fuel from thin air, how quickly will decentralized hydrogen reshape the future of global commercial logistics? I mean, if an isolated base can cut its reliance on global shipping lanes to power heavy-lift drones, it really is only a matter of time before commercial shipping, freight, and disaster relief follow suit. The 2026 hydrogen leap isn't just about building better drones. It's about fundamentally redesigning how the world moves heavy payloads. Thanks so much for joining me on this explainer, and I'll catch you on the next one.